Now for the next part of the lab, questions 1, 2, and 3 will guide us through using our data to achieve our goal of finding G. So in our data, in our table, we've recorded acceleration, angle, and sine of the angle. Our goal is to use a graph of A versus sine theta and analyze it to find G. Okay, question 1 in your lab report asks you to draw the free body diagram for the cart while it is on the track. Let's go through the idea of what you have to do there. Question 1. So we'll draw our track on an angle. This angle is the angle theta, so that one you varied probably between 2 degrees and 8 degrees. Here's our cart on top of the track. Whenever we do something like this, we have to pick a coordinate system. Typically, we're going to choose the x-axis parallel to the track and the y-axis perpendicular to the track. For our free body diagram, we draw the forces where they occur. So our weight vector points straight down. So that's the force due to gravity, Fg. The normal force is perpendicular to the plane and straight out. And our friction force slows the cart down, it opposes the motion. So the friction force is kinetic because it's moving and it's up the hill. We think about which forces do we have to break into components. The normal force is perpendicular to the track, that's all y, that one's good. The friction force is parallel to the track, that's x, that's all good. The gravity force points straight down. Part of it is parallel to the track, part of it is perpendicular. We do have to break that one into components. So the y component is the piece that's parallel to the y-axis, and the x component is the piece that's The y component is the part that's perpendicular to the track, parallel to the y-axis. The x component is parallel to the track, parallel to the x-axis, Fgy, Fgx. If this angle is theta, then this angle is theta. Okay, so this is what question 1 asks us to do. Question 2 asks us to write Newton's second law in the x direction for the cart. So question 2 says, write the sum of the forces in the x direction equals mass times acceleration in the x direction. So sum of the forces means add up all of the forces that are parallel to the x-axis, parallel to the track. So parallel to the track, we have the friction force. It's up the hill. Down the hill was positive, so friction is negative, minus Fk. Then Fgy, that's perpendicular to the track. That's the y component. We want the x component here. Down the track is parallel to x, so plus Fgx equals m times a. The cart accelerates down the track with acceleration a. In your lab instructions, it says include m, a, and theta and g in your equation. We're not quite there yet, so let's think about how we write down Fgx. In this triangle, Fgx and Fgy, they're perpendicular. They're the legs of a right angle triangle where Fg is the hypotenuse. Fgx is opposite the angle, so we can use our sine function to write Fgx. So this side is opposite, we can use sine theta to write that. So minus Fk plus mg sine theta equals ma. So that's question 2. Write Newton's second law in the x direction. That's done. Question 3 will now talk us through how to go through the analysis. So let's have a look at question 3. When you make your graph of A versus sine theta, you'll probably see that your graph is linear. That's absolutely what we expect. So A versus sine theta is linear. We know from a math course that linear graphs have the form of y equals mx plus b. On the y-axis, we're going to plot our acceleration. On the x-axis, we're going to plot sine theta. So our goal to figure out how to find g is to take our equation from question 2, rearrange this equation so it says A equals. So A is on the y-axis on the left by itself, everything else is on the right. So we want to rearrange this equation so that A is on the left by itself, everything else is on the right. So let's just write down that equation once more. Minus fk plus mg sine theta equals ma. So ma equals mg sine theta minus fk. Now I'm going to divide both sides, every term on both sides by m. On the left, ma over m, that's a. On the right, m's cancel, I've got g sine theta minus fk over n. Okay, we've done what we set out to do. We've rearranged our equation from question 2 so that a was on the left, everything else was on the right. Let's line it up with y equals mx plus b again. So y equals mx plus b. And let's see if we can figure out what stands for what. So a and y are the same thing because a is on the y-axis. Sine theta and x are the same thing because sine theta is on the x-axis. Slope is in front of x, g is in front of sine theta. So g must be the slope and our intercept is related to our friction term. Okay, so this is your analysis method. You can find g if you can find the slope of your graph. You can do that with your graphing skills. And then we have some questions about relating the intercept to the friction. That should take you through how to do the analysis for this lab.